Here's our calendar to finish off the year. Actually made my copies too. So tomorrow is like one more lesson, but it's regression. It's really not different. You've done regressions before. Now they're just going to be logarithmic. You choose a different equation in there. So this shouldn't be too bad. There is a new thing called residuals. So it's okay. It's kind of weird. And that'll be thrown at you tomorrow. And then that's it. We'll shut it down. So the homework that you get is that lesson plus anything else that would be on the calculator test. Then I'll give you the non-calculator review probably tomorrow as well. I just have them 2 different days here. Though I guess this is what the people said, the others, the no calculator test is Thursday and then calc is Friday. Probably be a lot of time in between those or after those tests, so I'll probably give you the review packet Thursday for the final. That's a doozy. That's a big one. Did I tell you what doozy comes from? Where that word comes from? It's from a car in the 1930s. It was called a Duesenberger. It's a very, very fancy, schmancy car. So if you that's a doozy, man, that's really cool. Get it? You can take that in your little vocab of uselessness that Mr. Samuelis tends to give every once in a while. It might be on the final too. What? All right. Okay. I don't know what all this says. You can read it. We got to make sure we know how to solve inequalities. I'm just going to do it. How do you solve an inequality? You basically solve it like an equation. Hey, what happens when I divide both sides by a negative, though? 3, 2, 1, go. Flip. So there's something else we need to remember. Then I have a way, like I was telling you how I'm liking this more and more. Like whatever I do to one side, say it. I like that more so than changing a log to an exponent, even though we don't even need to do that. Because when you change a log to an exponent in an inequality, who goes on what side? And you got to be careful. That doesn't even apply. When it applies, I'll tell you what I mean. This one's fine because I can get equal degrees, right? By the way, exponentials have no domain issues. So I'm just going. And then drop those 2 or 3. Sorry, saw that 2 in the x plus 2, and I accidentally said that. So drop these 3's. 3 to this power equals 3 to that. And then subtract. And then you could kind of check your answer. It makes sense. When I plug in 1, 1 plus 2 is 3. 3 cubed is 27. 27 minus 4 is 23, but 23 is not greater than 23. That's why it's not included. But if I plug in 2, if you look at the key, I think it's Mrs. Gray's writing today. She does a little number line check. She checks 2 and 0 just to make sure that it is shaded this way. And it is. I mean, it makes sense. 2 in there. 2 plus 2 is 4. 3 to the 4th is 81. Of course, 81 minus 4 is greater than 23. So I don't think we need that. Right? Everyone good? Okay, now we got a logarithm. We got some problems, though. What restrictions are there with the arguments of these logs? So we got to take care of that first right here. For that one, it's got to be x is greater than 8, right? Can't equal 8. I can't log 0. This one's just an expression, log 2, or no, that's a evaluatable, so there is no variable, there is no restriction. And then subtract 4, divide by 3. X greater, so -1 would work, and -1 certainly does work. -4/3 is smaller than -1. -1 would be a nice one, right? You would get an evaluation out of that. Hey, who's more restrictive? Meaning, what is the domain of the overall situation then? Is it the first one or the second one? Which one dominates? 3, 2, 1, go. First or second? First. This is worse. This has less numbers, meaning 7 doesn't work in this list, but 7 works over here. So I can plug in 7 over here, but I can't plug in 7 over here. So that is the domain of the overall situation. What you got to be aware of is you can't have an answer that has any of those numbers in it when you're solving this inequality. All right, now after all that rigmarole, we'll do our stuff. And then this one ends up being pretty easy. It's a product. And again, I'm teaching this like you know your rules. On the left again, when it's log some log, it's log of product of those two arguments. If you don't know that still, you're severely and totally anyone behind. Okay, fine. Whatever I do to one side, say it. Let's just play along that I 10 raised to both sides. That's really what's happening. That's why we could say we could drop our logs. If you're concerned, when do I drop the logs? 10 raised to the log base 10 is this thing free. And then I'm going to do a substitution. 10 raised to the log base 10 of 3x plus 4 is just 3x plus 4. You have to check my, you got to check this. Oh, never mind. Okay, no. I got Lexi's got to go to I got to take her to the doctor today, so I got to make sure she got the message. All right. Okay, now I'm going to subtract 2x from both sides because I want this to be positive over here. I want to avoid the divide negative flip thing if I can, but then subtract 4, you do get negative 20, right? Subtract 4, subtract 2x from both sides. Subtract 4, subtract. I can't believe I'm writing this. Come on. This isn't equation solving 101. You got to be able to flip this around and then, I got a problem. Can x equal negative 20? Can it? Oh, I can't plug in negative 20 over here. This solves this basic equation, but not a logarithm. You can't log negatives or 0. So actually, the answer is x is greater than 8 because it can't even equal 8. So x is greater than or equal to negative 20 runs through 8 and past it, but I can't have anything before 8 or at 8. So the restrictions took over, and that's the answer. Got it? So I could plug it in and prove it. If I plugged in 9, for instance, I just want to feel good about myself. Log 9 minus 1 is 8. Well, of course, 9 times 3 is 27, which is 31. This is much larger. Log base 10 of 31 is much larger than log 1 plus log 2, which would be log 2 if you did the product rule. So, of course, this makes a lot of sense. All right, next one. What can't or what is the domain? I guess I should be putting that domain. And this is, think about it for a second. 1, that was a second, because I do want to get those that didn't finish Friday up on the board real quick or around the boards. X has got to be greater than negative 3. So subtract 6, divide by 2. That's what X has to be greater than. All right, so be aware of that. Okay, and then this one's ready to go. But this is what I mean. If you do base exponent answer, who goes on what side of the inequality? This is why we are going to want to do this. We're going to want to 2 raise to both sides. I know that's weird. Whatever you do to one side, say it. Do the other. We're going to make 2 the base of each side. Wild. Why? What's 2 raised to the log base 2? The thing that's in there. 2x plus 6, the exponent. That's what it is. 2 raised to the, well, I turned this into an exponent, so it's that 2x plus 6 that's left over. And now wrong. Then I can leave the greater than as is, and I didn't have to worry about what side to put what. All right? So it is a really good way to look at things now. The regulars we're going to solve after break, and I'm going to show them this way only. I'm going to show whatever you do to one side, do to the other. 2 to the third is 8, minus 6 is 2, and then x is greater than 1. Some of your keys, no, your keys probably don't. Your keys probably show a lot of, but all the AP keys show the 2 raised to the power step. They all show that. And this should make sense. 1, I can't plug. That's weird. Yeah, because if I plug in 1, 2 times 1 is 2. 2 plus 3 is 6. Log base 2 of, or that's 2 plus 6, which is 8. Log base 2 of 8 is 3, but 3 is not greater than 3. It's equal to. So that's why it's greater than this, what I can plug in. So for sure, if I plugged in 2, 2 times 2 is 4. 4 plus 6 is 10. Log base 2 of 10 is certainly larger than 3. Higher power on 2 than 3 gets me to 10. So this is good. Okay. Ooh, I like it. What if I change it to a less than? So log base 2 of 2x plus 6. You don't have to write this if you get it, but if this was less than 3, you'd still get 1. So x is less than 1, though, this time. It'd be less than. The problem is less than 1 goes all the way down to negative 3. It can't go past negative 3. So then that's when you incorporate the restriction. Okay. So if it was less than, it would be less than 1, but we have a problem with the domain. It can't be negative 3 or smaller. So I got to stop there. You have to incorporate the domain issue. Got it? All right, saying that a few times over and over again to be repetitive to make sure it sinks in. Okay, now we're going to do it again. Whatever I do to one side, do to the other, because then it really holds the inequality where it's supposed to be, and then you don't have to really worry about a number line check. If you look at the notes key, number line checks are plugged in, possibly. Okay, well, do that, and then what I do to both sides is, we'll go blue this time, e raised to both sides, right? And that's why the ln's can drop. So then it is x plus 4, that's an identity, equals, did I do something wrong? Oh, it's times. You know, that's the second time that happened. I looked at this and I kind of incorporated it into that. My bad, dogs. Anyone? Roof. Nobody. Is that what you were raising your hand for? Oh my gosh. I'm making mistakes left and right. That's not equals. That's less. How embarrassing. I'll still put the video up. So I don't care. Couldn't care less. All right. Subtract x, add 18. And next, x is greater than, how'd that happen? Okay, x is greater than or equal to 11. And you want to write it like that. Oh no! What didn't he do yet again? His restrictions. So x has to be greater than negative 4. X has to be greater than 6. Who would you take? Which one's more restrictive? Which one do I have to worry about the most? The 6 one. Okay, but x greater than or equal to 11, does it even come into play? No. Okay, no, it doesn't. Right? You wanted to check that, 11. 11 plus 4 is 15. 11 minus 6 is 5. ln of 5 plus 3 is ln of 15. So that's when ln 15 is equal to ln 15. Any number bigger than 11, like 12, this will be larger than that side. 12 plus 4 is 16. Actually, this will be smaller. 12 minus 6 is 8. ln of 8 plus ln of 3 is ln of 24, when this was ln of 16. Get it? Obviously, ln of 16 is smaller than ln of 24, because you're looking for a power on e that equals those two numbers. Anyone hear that door move? I was afraid that I got what's it called? What happened on Friday? ICUC. Wait, what is it called? See something, say something. All right, that was fun. Okay, this is the way AP does stuff. Is this the last one? Were you absent Friday? Oh, it was exciting. I almost got taken out in cuffs, arrested. Anyway, let's just tell her that so she believes it. 1 minus 4 times 2 raised to the x minus 3 is less than or equal to negative 31, right? Now we're back to an exponential. There is no restrictions on exponentials. So you just go, you get going. Subtract 1. Oh no. Maybe this is why they're doing this. What do we have to do next? What do we have to do next? What do we have to do next? Divide by a what? What do we got to do? Flip. So 2 raised to the x minus 3 is greater than or equal to. Oh, and then here we go again. They were nice. If you had to change this to a logarithm, be careful. What I would do is log base 2 both sides. Let's just do that so you understand what side stays on what. but this is a no calculator one because what's log base 2 of 8, everyone? What's log base 2 of 8? But log base 2 of 2 raised is just x minus 3. So I'm getting to the point where we haven't had a good example where an exponential had to be done by a log. You know, you got to make sure you log both sides so you know that the x minus 3 is still on the left side of the, the balance here. And then this is 3, and then x is greater than or equal to 6, and there is no restrictions there, right? Okay, I think I did that right. So x is greater than or equal to. Okay. Next. All right. And I was wondering about this, and the last one is just like a common sense one here. Well, really what's happening is this. So we'll write this. What is this graph off to the side there? What? And I thought that too. I'm like, why is this over there? And then I'm like, all right, well, minus log base. Well, I know, well, okay, wait, this is a quadratic. So here I have a problem with the domain, like x cannot be, or x has to be greater than -3, right? Right? That's that domain. And by the way, we're supposed to have this greater than 0. So I was trying to do the AP like version of how they ask these questions. Oh, okay. Then I thought, all right, that's a quadratic. So first of all, that quadratic goes up. And boy, I'd like to know where the vert. Oh, well, you know what? They have the picture over here. Input, say it. What are all of these outputs? What kind of numbers are they? According to this, what are all these outputs? Starts with a P. I don't know what's going on. Positive. That means, are there any restrictions of logging this expression? Yes or no? No. That's why they gave you the picture. So the only domain issue I have to worry about is the one that I see right there. So they're making you not have to do the work of, what kind of graph is this? Do you get any negative outputs? Because then if I log that, I get a negative or log of a negative, which doesn't work. All right. So it took me a while to figure that out myself. Okay, you know what I'm going to do? I am going to do the division rule. It is minus, right? So it's x squared minus 4x plus 7. Almost done. And we got that little money problem. X plus 3 is greater than 0. This is what I mean. If you did that, well, I think it'd be better to do this so then you know what stays on what side. 10 raised to both sides. Make both sides 10's the base. All right? Because 10 raised to the log base 10 of all that garbage is all that garbage. Just a lot of stuff to deal with. It's not really that hard, though, once you find out what I'm doing here. And then this is over x plus 3. And this is greater than, what's 10 to the 0, everyone? 1. So if you would have done a, it's fine. You got to know that the argument is on the left side, though. That to me seems like another rule to remember. And then we crisscross multiply. By the way, bless you. By the way, when you crisscross multiply, who goes on this side? The x squared or the x? Who goes over here? Because I'm going to leave this as greater than. So who goes over here? X squared or the x plus 3? Which one is it? It's the x squared. This is a rule. When it's equations, I might have been like a little liberal on this. I don't really care who I put on the left side and the right. Because bless you again. If I didn't say that, he was going to get mad. You said bless you to them. Why didn't you say bless you to me? Call his lawyer. All right. And then 1 times x plus 3. All right. So it is the upper left goes on the left side. All right. Lower left goes on the right. We can prove it by checking our answers at the end. It makes sense. And then this becomes x squared minus 5x plus 4 is greater than 0. All right. And it is kind of important because we still have to do an analysis on this inequality. What multiplies 4 and adds to -5? -4 and -1. And then if you remember, for greater than, we thought of this as a number line here. And here's 1 and here's 4. And we also thought of this as a graph going up. If we would have switched sides and put this on the right side and this on the left, then the graph would either be going down or the inequality flips, and then you're doing the wrong analysis. All right? But input, say it. What am I looking for, above or below? Above. So here are the answers. Wait a minute. This goes forever to the left, but then we can't have -3 or less. So it's from 1 to -3 said in a really bad way. So -3 to 1. And then this wasn't equal to, was not equal to, then union 4 to infinity. We could check this in case we're worried about input output and having some problems. So I can see how 1 might be like right on 0. 1 squared is 1. 1 plus 7 is 8. This is going to be weird. Yeah, log base 10 of 4 minus log base 10 of 4 is 0, right? But it equals 0. That's why 1 is a threshold number. If I plugged in 0, that's kind of easy to plug in. You get log 7, then 0 plus 3 is 3. So log 7 minus log 3 would be greater than 0 because log 7 is bigger than log 3. Anyone hear me on that? Okay, so that's input, say it. This is doing a number line check. I think the notes kind of show that, and then I think she kind of shows that she checks 5, and then maybe 3 in between, and 3 is a false. Okay, but I can do that with graphs. All right, did the first bell ring? Not yet? Yes? Not yet? Oh, we're doing good. Okay, last one. Remember I talked about money with you guys? When do you invest? When? The midlife? No. When do you invest? Now. And then when do you pay down debts? Whenever you can. All right. So what's the continuous equation? So P times E, PERT. Some people used to know PERT shampoo. I don't know if it's still a shampoo or not anymore. Oh, sorry. And then what's the rate? 0.085. Please know how to deal with decimals and percents. 0.085. Oh, so when will your account be more than 1 million? So that's the greater than. No, that's where the greater than is. But I kind of common sense this out. Last hour, I just solved the equation, and I said the time's longer than this number, right? So it'd be t greater than the time that you find in this equation, correct? Yeah, I mean, that should really make sense. But anyway, how I put this and whatever I do to one side, do to the other is going to work out real nice. Oh, 250 grand. That's 4 times to get to 1 million. And then this is e raised to the 0.085 t. And then I'm going to ln both sides. We're going to keep doing this. Then this tells me what side I'm on. It tells me where everything is supposed to be. ln of 4 is less than ln of e raised to the 0.085 is 0.085 t. Then divide by 0.085. And that's what I mean. T, let's do it this way. T is greater than this, whatever this turns out to be. It's time greater than this time that will get me more than $1 million. This is the time that gets me 1 million. It's time longer than this. Okay, that should make sense. What, did anyone type it? 16 something? Nobody typed that? I think it was 16 point something. 16.3 something.